Let's prepare for something interesting. I promised you that we can remove all this code with just one line of code with really cool arithmetic. So can you think of new value for node y such that if node y was 300 it becomes 0, and if it was 0 it becomes 300? Well, sounds scary. There are a lot of things that you can try, and the thing that does the job is looks kind of strange. I'm not sure how to give you hints for it, so in case you are not a really epic genius, I guess you haven't think of just 300 minus node y. Wait, what? Is this really working? Let's think of what is going on this line if node y was, for example, 300, just like in the beginning. Well, how much is 300 minus 300? Oh, this is good. The result will be 0. And yes, exactly. After we've been on y 300, we should really go to 0. But let's check the opposite step. If we're on y0, if the node is on y0, what will be the result of 300 minus 0? 300 minus 0 and everything minus 0 is exactly 300. It doesn't change. So the node will move from y0 to y300. Apparently this line of code looks like it should be working. Let's see if it is really working. Now the node is in the down corridor and it moves probably in the up corridor. That's great. Will it move back to the down corridor? Yay, it did. So our crazy one line of code really saved us so much ifs and elses. Sometimes this can be done, and sometimes you will really need ifs and elses. Try this line of code yourself, experiment with it, because in our homework we will have a task to change corridors not of the node but of the player. So I hope you will be able to use this line yourself. You can do it also with the ifs, of course. Now I'm going to start with a completely new task for you. I will try to understand when the player catches the node. This is important and difficult task in games like Jetpack Joyride. In our previous game, both the player and the enemy could be on totally specific y's, and so they could collide in a lot of ways. The player could be here and the enemy could be here, and they could just touch a little bit if they move like this, or in the almost the same position they will not hit at all. And it's hard to check when we have a collision, when they are really hitting each other. now it's not like this. In this game it will be really easy to check for a collision, to check whether the player basket for notes catches the note really, because they need to be on exactly the same Y. I can easily write an if checking the opposite. If I told you one new knowledge, I want you to write it. Just after we learned about ifs and elses, we knew that we can write two numbers in their round brackets in order to compare those numbers, and I can write the y's of the note and the player, and I can compare them. For example, if the player have bigger y, he's obviously in the down corridor and the note is in the up corridor, and obviously the player misses the note. But we will have to have the same if one more time with the opposite sign. And this is just about the case where the player misses the note. We could have some difficult elses to check somehow about catching the note, and this is really hard. Instead, I really plan to tell you a new knowledge, and this knowledge is exclamation mark equals. Those are two signs. We should write them next to each other, and we use this sign to compare two numbers. We will check whether they are different. So this will be easier than the two ifs I had previously. This will tell me whether I miss the note. Here I will write missed the note, and I can have else, in which I can write got the note, you got the note. Let's see how this is working. I will first try to miss the note. Let's see what's going on. Well, I have epic bug, because on the first time I missed the note and the game said I got the note, and when I got it, it said I missed it, and now it will say I missed it. And when I go to the down corridor where the note is, it will say I missed the note again. Apparently this console log is printing exactly the opposite. Maybe I am telling you exactly the opposite sign, exactly the opposite meaning. I said that this sign means compare whether the two numbers are different. Well, this is really what this sign is doing, but we're comparing the position of the player with the new corridor of the note, and this is our mistake. This is really hidden mistake, and you will need a lot of console logs. Perhaps one console log that could help you see this strange bug could be printing here note y and my y. This is a useful console log when you try to find a bug about variables used in a condition. You better print those variables. Luckily, I was in a mood to tell you my bug, and I will now fix it without more hesitation. And now I will first check whether we are in the different corridor with the node. Print we missed it, or in the other situation print we got it. And when we are finished with all the printing, finally I will move the node in the opposite corridor. Now my printings will be correct. Now it will be printed that I missed the node. And now I hope I will see you got the node. Yay! I will try to catch it one more time. So apparently everything is working now fine with our check for missing or catching the node. But I will try to do it in much more ways. I will change this exclamation mark. I written it with Shift and 1, but I will now change it to one more equal sign. This is the opposite sign. It will not check whether the numbers are different. It will check whether they are equal. This is really scary sign because a lot of kids in my courses mistake this sign for this sign. You should really see the difference. This sign, we learned it in our second lecture, and we use it to change the value of a variable to some evaluation. When we are using double equal sign, we will make a comparison between two numbers. They both can be actually expressions. So only in this case you need a single variable in the left side. Here you can have scary evaluations on the both sides. For example, this scary evaluation will check for the same thing. Of course, you don't have to write difficult things just to have evaluations. You can keep them simple evaluations, like a simple variable. If we change the sign to r equal to equal sign, then we will need to change the texts printed, because in the else the code will be executed if they are not equal, and the first curly brackets will be executed if those numbers are really equal. So again, my program will still work now. And I will get you missed it sign, and now I will get you got it. So I want you now to know a lot of signs for comparison. I think I teach you those in the previous lesson. Today I showed you how to use check for equality and check for are different. And I will show you two more signs. This one is the left smaller or equal to the right one, and this one is the left bigger or equal to the right one. I hope you write them in your sheet of paper with all our knowledge, with good explanations, because you will use them many times and you will have to do the difference, to understand the difference between them. I think I'm ready to show you our homework. The most important task will always be write your sheet of paper, write to your sheet of paper all our knowledge. This time we have not a lot of knowledge, just few new signs for comparison. Let's go to the next tasks. First, I have written some tasks, but apparently I've missed the most important thing. Let the player move to the upper corridor with the mouse going up. This is the easiest task that we didn't do all of our lecture today. We made the opposite. We made the player moves to the bottom corridor when the mouse is in the bottom corridor. I'm pretty sure that most of you already did this task. So let's look at the more difficult tasks that I now have to change their number. So the first task that I want you to do will need a new variable called speed. Each of your new nodes have to be slightly faster than the previous node. So all our nodes are really slow, because on this line of code we are reducing node x with just 1. We can change this to 10, but again all of the nodes will be faster but with the same speed. This is boring. Let's change it. Let's make each node faster than the previous one. You will need a variable node speed. You should think what should be its initial value and where to change it and where to use it. In the next 3 tasks, I will want you to make totally different controls for the player. I will want you to write code in key up or even in mouse up parts of our code if you don't know what they are used to. Well, the code that we write in key up is executed when we release any of the keys on the keyboard, and the code in mouse up is executed when we release the left mouse button. So I hope this is easy task for you. But which one of all these three tasks is the easy one? I don't know. Perhaps all of them. So in task 3, I want you to make moving in the up corridor for the player on key up. Perhaps you just have to write here just one line of code that moves the player, changes my Y, so that the player is in the up corridor. I think you can write such a line of code. We had a really difficult, much more difficult lines of code today. I want you to write something in mouse up that does exactly the opposite. Moves him in the down corridor, changes its my Y to a big number like 300. In task 4, you will need to change something in our curly brackets. I will help you now with it. I will copy all of the key up function. You can see that I even take this closing curly bracket. This is really important because all of the brackets come in pairs. So if I want to have a new function like key down is a special thing that we can add if we want something to happen when a key is pressed down. So I want you to make, when the player presses a key, the basket for nodes to move in the down corridor, and when the key is released, the basket to go in the upper corridor. I think you've seen such games in which we change the direction of the gravity and we move when we press a key in some direction and when we release it in the other direction. This will be interesting experiment, but like a code, it's almost the same like the previous one. You will just have to take a line of code from mouse up, the line of code that you written here, and move it in your new function key down. You will have no problems as long as you keep your curly brackets intact. Task 5 is yet again for new controls. I want you to make the player be controlled only on key up. So now we don't need mouse up, anything, or key down. Only on key up something is going to happen, and this thing is changing the corridor with the opposite corridor. So you will need to take a simple line of code that we already written, but we written it about the node. You will be able to easily change it to change the corridor of the player. Task 6 of your homework is almost done. We already have if checking whether we got the node. Now I want you to increase a new variable called score. Also decrease lives remaining, a new variable for the lives remaining of the player. And if the remaining lives are too small, for example 0, write game over. All of this is the easy tasks. Task for harder thinking is how to stop all of the game when the player has lost all his lives. This is the thing that I want you to think about.